Recovery 2.0 was developed as an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy. One component of our strategy incorporates the use of brine electrolysis. In our ongoing quest for clean water, we are continuously searching for additional sources of feedstock, such as wastewater, seawater, and brackish waters. By utilizing a thermal reduction method to evaporate or distill these feedstocks, we are able to produce clean water. As we evaporate water from the waste feedstock, the residual mineral salts become concentrated. The more water that is evaporated, the more highly concentrated the brine solution becomes. As we continue to evaporate the water, at a certain point the mineral salts begin to crystallize. The salts are extracted in sequential steps, beginning with calcium and gypsum, and then the sodium chlorides, magnesium, potassium, lithium, and the residual heavy metal residues. The sodium chloride fraction, in the form of a concentrated aqueous solution, is further refined by electrolysis. One such method used is the chlor-alkali process. This is a very energy-intensive process and is a large consumer of electricity. The chlor-alkali process typically consumes roughly 2,300 to 3,000 kilowatt-hours of electricity per ton of product output. In the chlor-alkali electrolysis process, an electric current is passed through the sodium chloride brine solution, breaking the solution into three fundamental products. The first product is hydrogen, with a chemical symbol of H2. This is a clean hydrogen product that may be sold as a fuel or chemical reactant. The preference in the Recovery 2.0 process is to use the hydrogen as a reactant in our CO2 management and recovery process. The second product is chlorine, with a chemical symbol of Cl2. There are many applications for this product, such as bleaching, cleaning and manufacturing, as a building block for PVC plastics, ammonia production, and in the disinfection and treatment of water. In the Recovery 2.0 process, our intended use of the chlorine gas is for the conversion into hydrochloric acid, or HCl, which may be used in the recovery of metals and oxides. The third product is sodium hydroxide, also known as caustic soda. This is a versatile chemical used to make numerous products such as soaps and detergents, and is also used in chemical manufacturing, aluminum extraction, and food processing. Within the Recovery 2.0 process, the preferred use of the sodium hydroxide is as an absorbent of dilute CO2 in our recovery process. Sodium hydroxide is an intricate component of a hydroxide cycle. In summary, electrolysis of brine is a very energy-intensive procedure that consumes large amounts of electricity. We may be able to justify the cost of this process, but only if a source of cheap and abundant electricity can be found. Some of the costs may also be brought into an acceptable range by operating a default multi-stage, multi-material residual management approach, of consolidating byproduct residues in order to recover the strategic values from each of these materials. The recovery of brine electrolysis products allows us to extract beneficial values from residual waste materials. The Recovery 2.0 process was developed by Waste.net in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us at www.waste.net to learn more about the Recovery 2.0 process.